Hello and welcome to Wednesday's recording. So this will be for Wednesday, March 16th, and today we are going to cover Unit 4, Lesson 8. So by the end of today's class, we will be able to prove theorems about isosceles and equilateral triangles and apply those properties to solve problems. So here's a list of vocabulary terms that we are going to cover today, and each of these relates to parts of isosceles or parts of equilateral triangles. We are going to look at the legs of an equilateral or legs of an isosceles triangle, what a vertex angle is, a base angles, and then the isosceles triangle theorem and the converse of the isosceles triangle theorem. So recall that an isosceles triangle has at least two congruent sides, and the congruent sides are what we call the legs. So in this diagram down here, we have a single tick mark on two of our sides, so that means this is a leg, and this is a leg. The vertex angle is the angle formed by both the legs, so that makes angle 3 the vertex angle. And the side opposite the vertex angle is what we call the base. So this side down here would be called the base. And the base angles are the two angles that have a common, the base is the common side. So we say angle 3 is the vertex angle, angle 1 and angle 2 are what we call the base angles. So let's talk about our first two theorems involving isosceles triangles. The first theorem is called the isosceles triangle theorem. And this theorem says if you have two sides of a triangle given to be congruent, then the angles opposite those two sides are congruent. So here we are given that AB is congruent to AC. And the conclusion we can make is that the side opposite AC, which is angle B, is therefore congruent to the side opposite side AB, or angle C. So when you have two sides of a triangle congruent, the angles opposite those sides are congruent. Now this theorem also has what we call a converse, which states the opposite is true. This theorem, the converse of the isosceles triangle theorem, says if two angles of a triangle are congruent, such as E and F, then the sides opposite those angles are congruent. So that means DE is congruent to DF. And so we're going to do a couple problems involving these two theorems. Before we look at some problems, let's go over a proof of the isosceles triangle theorem. So in this diagram, we are given that side AB is congruent to side AC. We want to prove the isosceles triangle theorem. So we want to prove that angle B is congruent to angle C. That is the angle opposite each of those sides. We want to prove B is congruent to C. And we're going to do this proof by adding a midpoint to BC. That's going to be X. And we're going to draw what we call an auxiliary line, which is just a line to aid us in a proof, from A to X. Okay, so we once we draw our midpoint of BC, that means that BX has to be congruent to XC, and we draw in our auxiliary line. We can then use these two smaller triangles to prove that the two smaller triangles are congruent to each other. So we know that BX is congruent to CX. Those are the two lines I just drew in, and that is by the definition of a midpoint. We can also state that AB is congruent to AC. Those were our original two lines here and here, because that was given to us. And then we can use the reflexive property to state that AX is congruent to itself. And so now we've shown all three sides of the top triangle are congruent to all three sides of the bottom triangle by side, side, side. And then we can follow up Once we know that two triangles are congruent, we can state that all remaining pairs of corresponding parts are congruent. So then therefore, angle B here must be congruent to angle C using corresponding parts of congruent triangles are congruent, which is what you saw in Monday's recording. So now that we've proven this triangle or this theorem is true, now we can go ahead and use it to solve the next few problems. So here's our first one. So in this diagram, we are given triangle DEF with angle E measuring 22 degrees. We want to find the measure of angle F, this angle down here. So we can use the isosceles triangle theorem to say that angle D is congruent to angle F. So by the isosceles triangle theorem. And remember, this theorem just says if you are given two congruent sides of a triangle, then the angles opposite those sides have to be congruent. So therefore, D has to be congruent to F, and therefore their measures are congruent. So I can say the measure of, or their measures are equal. The measure of angle D must equal the measure of angle F, and that is just using the definition of congruence. Next, I can state that all three angles of a triangle have to add up to 180. If you guys think back, that's called the triangle sum theorem. So I can say that the measure of angle D plus the measure of angle E plus the measure of angle F has to equal 180 degrees. That is just called the triangle sum theorem. And then by this statement here, because D is equal to F, I can replace either D or F with the other angle. So I'll just leave D in here, and I'll replace F with D because they are congruent. That is called substitution. So I can say the measure of angle D plus the measure of angle E. I'm going to replace the measure of angle F with the measure of angle D because this says they're congruent, or they're equal measures, so I can do that. And that's just using substitution. And by combining like terms, I'm able to then solve this equation. So how many measures of angle D do I have? Well, I have 2. So 2 times the measure of angle D plus the measure of angle E has to be 180. And that is just combining like terms or simplifying. Now, I am given that E is 22 degrees. So I could have put that at the top. The measure of angle, the measure of angle E is equal to 22. That was given at the very beginning, so I should have stated that. Now I'm going to replace the measure of angle E down here with 22 degrees. So 2 times the measure of angle D plus 22 has to equal 180. That's just by substitution. And then solving this equation, I can subtract off 22 from both sides. That gives me 2 times the measure of angle D is equal to 180 minus 22, which is 158. So that's just using algebra. And using more algebra, I can divide both sides by 2, which tells me that the measure of angle D is equal to 79 degrees. So that's more algebra. So if D measures 79 degrees, then we know angle F also has that same measure. So this measure here is equal to 79 degrees. Let's try another practice problem to make sure we have this down. So here we're going to apply the same type of idea to this. We know that GH is given as congruent to HJ, right? GH is congruent to HJ. That's given. So this time I can make the conclusion that G, the measure of G, equals the measure of J. Measure of angle G has to equal the measure of angle J. And again, that theorem is called the isosceles triangle theorem. And so now I can just substitute each of those expressions in for G and J. So x plus 44 has to equal 3x. And that is just substitution. And now I'm able to solve to find the value of x. So I have x plus 44 equals 3x. I want to get all of my x's on one side, so I'm going to subtract x from both sides. So 44 is equal to 2x. That's just using algebra. And now I can solve for x. X is being multiplied by 2. So divide by 2 on both sides. Some more algebra, or our division property of equality. And that tells me x equals 22. So now that I know what x is, I can plug it in to find the measure of angle G. Measure of angle G is equal to x plus 44. And I know x, I just solved for it, is 22. So 22 plus 44 is going to equal 66 degrees. And we are done. So then now that we looked at two theorems involving isosceles triangles and we solved a couple of problems, let's go on to our last set of theorems, which involve equilateral triangles. We have two theorems involving equilateral triangles. The first says, if a triangle is equilateral, then it is also equiangular. So equilateral meaning if a triangle is given as having all three congruent sides, you can make the conclusion, well, then all three angles must also be congruent. And then from this theorem, we have what we call a corollary. This is just an addition or a shortcut to the theorem above. And so this just says it goes both ways, right? So because the first one says if a triangle is equilateral, then it's equiangular, we can apply the reverse. We can say if a triangle is equiangular, then it must also be equilateral. So if you are given all three angles are congruent, you can conclude that all three sides must be congruent. And so because both of these corollaries can be combined, they're both true, then it can be written as a biconditional statement. So that's kind of what we looked at back in Unit 3. And this is called a biconditional. We can put the words if and only if in the middle and make this statement true in both ways. So we could say a triangle is equilateral if and only if it is also equiangular. So let's take a look at a couple of problems. So here we want to find the value of x. Now I'm given a triangle with all three sides congruent, which means all three angles are congruent. And so what's nice about this is if we know a triangle has all three angles congruent and all three angles add up to 180, then I know each angle must be 60 degrees. And so if that's the case, then I know angle L has to be equal to 60. So 2x plus 32 must equal 60. And now I can solve for x. So I'm going to subtract off 32 from both sides. And that gives me 2x is equal to 28. And then to find x, I just divide both sides by 2. So x then has to equal 14. Okay, so I want to thank you guys for watching part 1 of the recording for today. I'm going to stop it, and then next we're going to do one more problem and then a couple of proofs.